All right, let's get right into it. Today, we're peeling back the walls on something you probably use every single day without a second thought, the elevator car. We're going to dive in and uncover some of the incredible engineering that's hidden in plain sight.
I mean, seriously, just think about it for a second. This is a room that moves up and down inside a building, sometimes at really high speeds. So what are the bones, the brains, the unseen guardians that make this daily miracle of engineering not just possible, but, incredibly safe?
So first up, we got to talk about the foundation. Long before you get the nice-looking walls and the fancy lighting, you have the core structure, this powerful, unseen skeleton that does all of the heavy lifting. Literally. At the very heart of it all is the car frame, or what engineers call the chassis. This thing is a robust steel structure with one absolutely critical job: to bear the entire load, the car itself, you, me, everybody, and connect everything to those suspension cables. It's the absolute backbone of the whole operation.
And what's interesting is that engineers have a couple of main ways to design this frame. The overslung design is the one you see most often, where the frame kind of wraps around the cabin to distribute the load from above. But sometimes, for buildings with weird constraints, they'll use an underslung design, tucking the whole support structure underneath the car. It's just a really clever way to adapt that core strength to whatever a building needs.
Okay, let's look down for a second. That floor you're standing on? Yeah, it's not just a floor. It's called the car platform, and it is a heavily reinforced steel plate that's been meticulously engineered to handle huge forces and stay perfectly rigid and stable.
And if you want to know just how seriously they take that stability, look no further than the safety standards. The platform has to be able to hold not just its rated load, but at least 125% of it without any permanent bending or deforming. That is a massive safety factor built right in. Okay, so we've got an incredibly strong box. But how does it move so perfectly smooth without swaying or vibrating all over the place? Well, that's the job of the guidance system.
This secret is these things, the guide rails. You can think of them as the elevator's spine. There are these perfectly machined steel tracks that run the entire height of the shaft, and they provide a rigid, unwavering path for the car to follow.
And the precision here is just staggering. To give you that smooth ride, the tolerance for how straight these rails have to be is less than 1 millimeter of deviation for every single meter of track. That is literally thinner than a credit card. It's an incredible feat of both manufacturing and installation.
The mechanics behind it are actually beautifully simple. The car frame is fitted with what are called guide shoes, or rollers, which just hug these rails. And that simple connection is what turns all that raw power into a smooth, stable, and perfectly controlled vertical journey.
Now, the type of connection they use really depends on the elevator's job. For your lower speed, everyday elevators, simple and super reliable sliding shoes get the job done. But for those high-speed elevators and skyscrapers, engineers switch to roller guides, which are basically wheels, to dramatically cut down on friction and make sure that ride is perfectly smooth.
Okay, so the car is strong, its path is precise, but what about the active systems that are protecting us every single day? Let's talk about the unseen guardians, starting with the one you interact with every single time, the doors.
We tend to think of the doors as just an entrance, a way in and out. But in reality, they are a complex, intelligent safety system. Their number one job is to be a barrier that will only open when it is perfectly safe to do so.
And behind that smooth, quiet operation are a few crucial parts. The door operator is the brain of the system. A critical interlock acts as a lock, physically preventing the car from moving unless the doors are completely closed and secure. And of course, you have those safety sensors, constantly scanning the doorway for any obstructions.
We've all done this, right? You stick your hand out to stop the doors and they immediately reverse. Well, that's not just a nice little convenience. It's a mandatory, absolutely non-negotiable safety feature. It's called the reopen function, and it's powered by a curtain of light that scans the entire opening.
And this obsession with detail goes right down to the tiniest measurements. Safety standards demand that the gaps between the moving door panels and the frames have to be less than 4 millimeters. That's an incredibly tight tolerance, all designed to make sure nothing, and I mean nothing, can get caught.
All right, so with this newfound respect for the structure and the safety systems all around us, let's step back inside the cabin, the part we're all familiar with, and look at the components we actually see and use.
Inside here, every single element has a purpose. The car operating panel, or COP, is how you talk to the elevator. The handrail is there for stability. And then you have all these critical components like the emergency phone, the alarm button, and backup lighting. They're all there as layers of safety and communication, just in case.
But here's a great question about one of those common features. You see a mirror in almost every public elevator, right? Have you ever stopped to wonder if there's a real reason for that, beyond just, checking to see if you have anything in your teeth?
And the answer is just a brilliant piece of inclusive design. The main reason for that mirror is accessibility. It allows someone in a wheelchair to see what's behind them when they're exiting, so they can back out safely and confidently, without needing the space to do a full 180-degree turn. Pretty cool, huh? So, as we bring this all together, it becomes really clear that an elevator car isn't just one thing. It's more like a symphony of different systems all working together in perfect harmony, and all of it is engineered for one single purpose: your trust. We've basically looked at the 4 core pillars. You've got the structural skeleton for that brute strength, the precision guidance system for a smooth journey, the guardian safety systems like the doors that actively protect you, and finally, the cabin experience, which is all about communication and accessibility. They all have to work together seamlessly.
And that's really the big takeaway here. The next time those doors slide open for you, I hope you don't just see a simple box. I hope you see this incredible synthesis of strength, precision, and intelligence, a true masterpiece of hidden everyday engineering.